Okay, you're live.
Excellent.
All right, so I'm going to minimize. I'm actually going to close this.
Excellent.
And you can go back to Max.
Perfect.
All right?
Yeah.
Good luck.
Thank you. Thank you. Can everyone see the table of elements closest to you? Pick one, stick to it. There's going to be a quiz at the end.
We have to know the song?
No, but I was looking for a positive reaction. That's my chemical joke.
Right next to Uncle Moon.
By the way, where we had the keynote, they had a table of elements, and they actually pasted a couple of, elements here. So this is a different table. Someone is cheating. Can the people in the back see? Because it's kind of bright room, so it's hard. Okay, perfect. But then we'll fall asleep, all right? Because I know my audience. Yeah. We have 1 more minute, to let maybe someone else will trickle in.
Oh, there you go, the trickler.
The trickler, yes. If you go to slides.com/Bahmutov, you will see the slides. They're public. They're right there at the top. And if you see the slides, you can actually fast forward for them and just go see something else today. Don't waste time. You get the gist of all, exactly. But you won't get my jokes, right? So those are only live. That's why you pay for this performance. Let me just take a picture as a proof. Okay, welcome to It's Not Your Parents HTTP. I'm Gleb, last name Bahmutov. I'm very active online. I have a lot of open source projects that I share on GitHub. All my presentations are at slides.com. I had a long journey from image processing and working exclusively in C, C++ to C#, CoffeeScript, Java, and finally arriving to the front-end world and working with distributed applications. Nowadays, I do Node, front-end frameworks, functional programming. If anyone wants around the functional programming sticker, talk to this guy right there. He will give you a sticker. So it's great to be here. Okay, my best achievement was writing a little JavaScript snippet that you can drag into your browser, and then you can go to GitHub, anyone's profile, and play game of life with their contributions. Sometimes you can find really interesting stuff. I worked around Boston in Massachusetts, so I worked at MathWorks for a while, so that's exit 13. And then I worked at Utah, so that's exit 12. And then I was like, I will not move to the west. So now I work remotely for a company called Cypress that does this amazing end-to-end test runner. So if you ever need to test a website or web application, you can just download this as NPM dependency and start testing. And you will see everything that runs in the browser. And it's free and open source and MIT license. OK, so that's useful. I do blog a lot because I forget things. And I found a solution, just write everything down. So I kept writing and writing things on all different topics related to somehow to testing and development and coding. And now there is more than 400 blog posts. And this means that I love sharing knowledge, right? I'm the opposite of patents and copyrights, right? I think by sharing knowledge, I become a better developer. I become a better engineer. Other people can do something cooler based on the things I showed them, and I can learn from others. OK, that's nice. Sharing knowledge is nice. This is probably because I went to grad school. And in grad school, you read papers, you share knowledge. And if you don't write papers, you die. Basically, you don't get tenure, you get fired. So the only way to get a career in any kind of academic world is to learn from others and produce something new that other people will build upon. So every scientific paper is kind of hard to see, but it's on the PDF. The last page is always the reference page. And it literally contains all the links. Because you cannot just say something like 2 + 2 = 4. You either have to prove it, or you have to say, here's a reference, someone proving 2 + 2 = 4. So there are a lot of references to other papers. So if someone wants to find out more, they have to go and read it. Which sounds nice, until you kind of think about this, right? So you're reading this paper, it's a printout, and you see something, and you're like, I want to read that paper. So what do? Well, nowadays, you go online. But before internet, you had to go to the library, find the book or paper, meaning journal, right, where it was printed, make a copy, go and read. And then like, oh, I want to read that, right? So it's kind of depth-first search, where every kind of iteration takes minutes at least, or hours, or if you have to order it from another library, days, months. Maybe you have to write to offer of a paper, hey, do you have a copy? Can you send it? And by send, I mean mail, postal office kind of thing. So it becomes a huge, huge castle, right? Because in order to create something new, you want to quickly gather all the relevant information, right? Track all the details, and then come up with something new. So imagine you are a researcher, and you work on a contract. And you don't work at University of Massachusetts Amherst, right? You work in Europe at CERN. And you see this problem, and you're like, OK, I can code, right? I can come up with a solution. And this one person says, OK, there is now this thing called internet, right? Computers can actually send something and receive something and ask for something. So I want to come up with a system where researchers that work at CERN, right, can just read the document, read some text, and when there's a reference, they can click on it, and it will go to that server somehow, and it will fetch the document and show them, and they can read. Not interrupting their work. They don't have to get up. They don't have to go to a library. Literally, they can just keep reading all the references, right? And keep going further and further. So this researcher filed a proposal, and it was dated 12th of March, 1989. So recently, it celebrated its birthday. And the proposal was for information management, right? Because you have to manage all these documents. You have to design a system that would not only show them, but also store them, make a request for them automatically, retrieve them. So you have to design several things at once. And of course, you probably guessed but this is HTTP protocol, a proposal. And the person proposing it right now has his name, Tim Berners-Lee, and the response right in the corner that he got back was vague but exciting. Okay? So whenever you start something new and you think it will completely revolutionize how the world works, if you get a praise like vague but exciting, that's the top, right? Like, don't even try to get to exciting. Just, it's okay. So the first thing that appeared a year later was the browser, right? And this is how it looked. Hypermedia browser editor. Now, the interesting thing here was on the top. So you had two buttons, and the top one says edit, and the one underneath it says find. So imagine you're creating a very, 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 very first library. You better be good at writing books, because there are no books, right? Because you're inventing whole writing, you're inventing the library system, right? So the first thing that this browser editor did was allow you to actually write a document so you can share it. So that's why the thing edit is on top. And it kind of looked like modern browser, right? It allowed you to display text. It had hyperlinks. The second iteration, a couple of years later, already had even closer to the modern look and feel, and it actually had find on top, because by now, and you will see the progress, people started writing a lot of websites. So it became easier to find something so you don't have to create it. That's great. Find moved on top. This looked like a modern browser. You had underlined links. But it was just part of the equation, right? It was just the viewer. You also had HTML, the markup language standard, but you also needed a way for the browser to ask a server, hey, give me this document, and send it back. So the proposal for that was HTTP, Hypertext Transfer Protocol. And the first proposal, that's the whole thing. You can find it online. And I apologize for resolution of a projector. But it was signed Tim BL. OK, very modest. I like his full title today because it has the word engineering 3 times in title. So that's kind of cool. But the whole thing is 650 words. I mean, I cannot say I've written tweets longer than that, but that's pretty short. And it has only 4 parts. The browser will make a connection. It will send a request for something. It will get a response, and then it will disconnect. That's it. That's the whole protocol. If a protocol, if a port number is not specified, 80 will be assumed as default. And there was a standard, like which ports were already taken, right, by like mail system, right? So 80 was available. It was round number. We might as well get we could have had like 78 or 53, but he picked a round number. Once the document was sent, the connection was terminated. You make a request, and you just have get and the path on a server. And the response was just hypertext, right? ASCII, no binaries, nothing. Just send me text. There were no error response codes. So the server, if it couldn't find your document, was meant to send you text saying, hey, I could not find it. And then the human would actually, oh, yeah, OK, something's wrong. And you can only get documents, right? It was document retrieval system. You could not upload the document. There were no cookies, no server, bare bones. Because he knew the principle behind any kind of initial proposal. Just get the bare bones system. You're not going to need it. Don't think about too much. Just show me the thing. And this protocol is now known as version 0.9. And the thing that it really is trying to solve is I'm looking at this document, HTML. It has a link, and I want to read that document referenced by the link. So the browser will go, grab it, show it. It would not actually go and do it itself. Instead, it would rely on existing protocol called TCP to actually do the connection and retrieval. So we think in abstractions. We think that the browser goes to the server, goes somewhere, grabs the document. In reality, no. The browser uses an underlying protocol, TCP, which uses underlying protocol IP that goes to the cloud and then goes to the IP endpoint here on the server, which goes to TCP, goes to the server. But we don't think about that, right? Every step here kind of just uses one underlying thing without knowing anything what the actual things are. But conceptually, we just say, oh, just connect to the server, get it. So because of that system, right, because of that stack of protocols where every protocol just relies on the bottom, on the one beneath it and nothing else, the property of HTTP, that means how the browser works, really depend on the property of the TCP, because the TCP is making the connection. And TCP has just two main things. It guarantees data delivery. That means I'll get you the document, and I will not lose any paragraphs. I'll get you the whole document. And it guarantees the packet order. That means I will get you the HTML document, and I will not mess up the order of paragraphs. It's kind of important, when you read scientific papers. It's like, oh, I was supposed to numb the patient before I cut him. Oh, that's okay. It had a thing saying the future HTTP iterations will be backwards compatible. That quickly got dropped because it's impossible. And when you think about it, right, modern aviation, we all love to fly, maybe not, without being frightened. If this were a modern airplane, right? Imagine airplanes only 29 years after the very first flight. They would look like this. Would you fly around the world in this kind of? But we use a system that's as old as this airplane, and it works. It's unbelievable. The number of websites immediately exploded, right? It was growing by a factor of 10 every year, because this was a useful system. Again, it escaped academic world, right? People started asking for features. I want to see an image. Okay, so the next iteration of a protocol called 1.0, we're like, oh, we need all these features. Okay, so the protocol grew from half a page to 60 pages. The request, now got headers. The main things in this iteration was we want to send non-HTML data. We want to have methods. We want to be able to upload a document. We want to have status codes that are machine understandable. We want to negotiate not only what the user wants, but also what format the user wants it in. And then a couple years later, we arrived at HTTP 1.1, where not only it was battle tested. As soon as we started using it World Wide Web for everything, we found some problems. So this was the solution. And now it became quite large, right? It was I forgot how many pages, but literally hundreds. And it went through many drafts. And the main things that the protocol now supported was performance. If you're running the whole information system for the whole world, you better make sure that you know how to do caching and how to specify connections. Security is kind of important. Some people think, I don't know. Also, we ran out of IP addresses pretty quickly, so we needed to host many domains. So this actually tells you how to do it. The organization behind HTTP and how it improves is called Internet Engineering Task Force. They have these proposals how to, like, anyone can do these things. And you can read, and that's where requests for comments are called RFCs, and that's what the official names and version for each protocol version is. And we assume that internet is all like nice and like in this little package, but in reality, HTTP and its implementation varies very differently, right? It's literally like this hodgepodge of old protocols, old servers, different versions, different features, different implementation, kind of working together, unless you peek under the hood. The best peek under the hood that I know is this book called Tangled Web. Unbelievable insight into why the web is so complicated, so insecure, and why nothing can be done about it. Like, really recommend this. Like one example, like we can make HTTP requests, but not to HTTP server, but SMTP server, like wrong port, really, 25 instead of 80, and it will just say, I don't know what you're trying to do. So it will send the response back, and if you just open it in a browser, you now have cross-site scripting attack because you just got raw HTML from someone that's not escaped. So there is always this mismatch between the request and responses because versions were not specified, because the protocol was not specified, because the port was not specified. So the security is kind of bad right now. It's constant battle. So every time you open a browser, you literally like, hey, everyone, come at me. And nothing can be done about it, really. One thing you could do, because we are in Amherst, there is a security meetup here that you can join and attend. And it's a small meetup, so you can learn something because it's not crowded. You can ask questions. OK, under the hood, it's still the same protocol, the same original protocol. I see a link, give me the page, browser goes to the web server, comes back with a response. OK? So if we think just at the user. The browsers don't allow you to do any other protocols. From a browser, you can't open a TCP socket yourself, bless you, and then connect directly. You always have to go through HTTP. So that's the only game in town. Used to be that there were no headers, right? You just make a GET request. Now, because the HTTP is stateless, that means the server will not do anything, right? You cannot say, hey, by the way, store my password here. You have to send all the state in request and response, which kind of blew up in size, right? Used to be there were no headers. Now, if you make a single request to GitHub, you get this whole shebang sent back and forth, mostly for security. You get your cookies, your cache headers, and then lots of stuff for security. So our requests and responses were increased in size tremendously. We sent a lot of tracking stuff, a lot of third-party libraries. Slash.org, a single page, actually makes 58 different requests to actually form a page. Remember, page was like, give me a page, got a page. That's it, one request. Now we literally making tens, if not hundreds of requests to actually get a single page content. The page became incredibly, overweight. Like 2 megabytes is average with videos and all the libraries and everyone loading their own libraries, right? By the way, so even the page, this is an excellent presentation, and they discussed all the public kind of discussion of this problem, where if you go to like CNET and read an article about how big the pages got, the page itself on CNET will be huge, right? So it's kind of a vicious cycle. But because the pages are huge and it takes a while to load them, the initial improvement on HTTP was, hey, why don't we create a mechanism for pages not to reload themselves? So if you just need something dynamic, just have a mechanism to ask for a part of a page to be reloaded. And surprisingly, it was Internet Explorer that introduced this feature by having an iframe element where a page could include another page. So you go to the first server, you ask for index, you see where is iframe, you go there. And the security is nice because you can isolate, and the iframe should not be able to like mess up with the parent page. And an improvement on top of that was XML HTTP request, kind of unwieldy acronym. But basically, you can ask a server for data, not a page, but just for data. And Internet Explorer did it, and then Gmail started using it a lot, and you got this dynamic web application, and that's what powers the application in websites. Now it's a standard. It looks awful because now you combine both HTML, which is a declarative protocol, with a whole bunch of scripting, right? So now it's not just HTML; it's completely new beast that you have to use, which is JavaScript. And just on a personal note, right? So HTTP was created pretty quickly, right? Half a page, boom, bare bones. JavaScript was created in 10 days just because they needed something to script pages, right? Like literally, the whole modern information technology and the whole modern world is literally built on hacks. So don't feel bad about your code. There is a new standard that tries to kind of standardize how everything the browser can fetch, right? Not just Ajax or Pages or CSS or whatever, everything. And it's called fetch, not surprisingly. And it's much, much cleaner. You just make a request, you get information, you decode it, you can use it. So HTTP 1.1 today, that's the modern thing. And here's how it looks. Again, it relies on TCP. It doesn't know anything about what's underneath TCP. It only knows what it can use, TCP. On top, people start building other protocols that use HTTP to actually implement themselves. Famous REST, and now GraphQL for fetching the data, updating the data. But it's not the only game in town. So when a client in a browser tries to communicate with a server, yes, HTTP. But you can also open a WebSocket, right? So if you know that you need binary duplex communication with a server, and it will be ongoing thing. It's not like one single round trip. You can open WebSockets, and now you can communicate. Or there is a WebRTC, which is completely different binary protocol, where you can also exchange data, not even with a server, but with another browser. And now there is a new kid in town called Service Worker that kind of puts a proxy between your page and the server when you're using HTTP. So there are all these different choices. But one thing that's very important is that the original HTTP, right, where you make a request and you hope for the best and you don't have any security, is no longer working. We do have to use secure communication, where you encrypt the channel, you agree on a common key, and no one can eavesdrop on it, right? Browsers keep adding new APIs. So not just video, not just grabbing your camera, not just payment, but Bluetooth, everything. So all modern things worth like learning about or discussing are all behind HTTPS. The browser will not allow you to like stream your camera to HTTP website because someone can actually intercept that. Luckily, there are solutions you don't have to pay for to have your website protected. Let's Encrypt is famous. I use it myself. Really simple and useful, automated way. No payment necessary. Your website is protected. Has been growing like crazy. Now they have wildcard support. That means if you're running a domain and you have a couple of foo.mydomain.com bar.mydomain, you can get a wildcard single certificate and it will protect your whole website. You don't have to ask for individual certificates. So that went live. That's a big deal. Security. So they initially expected, I think, January or February, but for sure it went like February or March. Wait, now it's March. Yeah. So yeah, pretty recent. Yeah, time is both flying and crawling. Yeah. Okay, bad things. HTTPS adds extra cost, right? Not only you have to establish connection like you had to do with HTTP. Now you have to do a couple of round trips so you can establish a common key and encrypt the channel first. So you have this, penalty for every connection. But you first have to protect it, then exchange the data. And that's expensive. So a couple round trips, only then you round trip and get the data. Service worker, right? So I said there is a new thing in town where when you use HTTP, you have this weird thing that's like a proxy running in your browser, and that's service worker. And that's very exciting technology. So that's a common thing, right? No connection, you are out of luck. Your website is not accessible. There's nothing you can do except... Does anyone know why they picked dinosaurs? Because they died off? Or they had no connection? Like, are we still dinosaurs? We just don't know about them? Because they're not on the internet? Well, they're birds, yeah, so what does that have to do with HTTP or connection? But anyway, so people try to kind of, again, a hack. You're just going to list everything you want to cache for your website, and the browser will store that, and that's enough. And turns out it's not enough. Just declaring what you want beforehand and then always sticking to it is very, very hard. So you need a solution that you can program using JavaScript. So the browsers had web workers, which was a separate thread where you could upload your computation for a while. But now they added this extra thread with service worker. And the main thing is the browser is making a request to load a page, to load CSS, to make fetch request, anything. And the service worker, like a proxy, could intercept that. And it could transform a NOT-that request, then send it to the server, get a response, transform the response if desired, and then send it back. To the browser, it looked like it was just making a request. It had no idea what was going on. So smart caching, you can really control what you're doing, right? If you could not make a request to the server, you would serve a cached copy. You could serve a cached copy first and then ask for update copy from a server. So it was really smart and powerful. And people do other things with service workers. The cool thing, again, it's very easy. You just say, hey, register service worker, and you would get it in your website. Must be HTTPS, right? Because that thing is really powerful. It can intercept every request. So you better be loading what you trust. If you load a malicious script, the game's over. Might as well pay someone now and empty your account for every user. Okay, couple events. Most important one is fetch. So fetch happens when the web page is loading itself, loading CSS, loading JavaScript, making AJAX requests. And you can control how to respond to that. Really powerful API. And I have a bunch of slides that actually show this and some cool things you can do. You can check them out. Okay, again, internet is a dangerous place, right? It's like wild, wild west. It's not World Wide Web. So imagine an attacker is loading a service worker that attacker can control. Now they can intercept everything. I see the dangerous thing in JSON-P, which was a hack to get around lack of AJAX and loading things. Not even lack of AJAX, of cross-domain restrictions. But basically, it was a way to say, hey, server, do something and get me some JavaScript that I'll execute with result. And if everything is fine, everything was good. But if an attacker could actually do a callback and load an attacker's service worker, then everything would be bad. And you could actually run malicious code as a service worker. And the bad thing about that is that imagine you're trying to say, OK, do not load the service worker. But the service worker already intercepting everything. So the next time the page is loading, it will just reinsert itself and reload itself. Now, I don't know how many of you try to tell someone how to diagnose a browser problem. It's impossible. You can't just say, open DevTools, go to application, clean your cookies, go to service worker. Oh, which version you have? Oh, it probably was name something else. Unregister your service worker. It's incredibly frustrating experience. Kind of like trying to clean up after a dental. So I have slides how to protect yourself, because if you don't allow cross-site scripting attacks, you're safer. Okay, so we covered these things. Let's look at the future, but it's today. HTTP2. The web was slow, so we had to do something about it. And I have this little video. New York Times. Loading NewYorkTimes.com. Okay, so I'm reloading the page. Look at all this crap. It's 130, 140 requests, 150, 154. Okay, so the page, 190, 230. Okay, you get the point. 250 requests to load freaking news page, right? Now, compared to the original design of HTTP, get one document, show text. Both are text, with graph. Yeah, there is graph, but everything, like all these fonts and CSS, it's pretty, but it's not information, right? We broke internet as it was designed. So how to quickly load 200 resources without making separate connections? Some resources are important, some not as much. So how to load some resources first? How to avoid duplicate data, because you're sending duplicate data and like headers. At some point, people figure out it's not the bandwidth, it's not how much you can push through connection, it's how long it takes to do each request. Because if you're doing 200 requests, you're doing 200 long things. So the latency is more important. So 10 years ago, almost 10 years ago, Google started a project trying to solve this problem, and it was called Speedy, and it became a standard 6 years later, and that became HTTP2. So Speedy developed, became so good that the governing body adapted that as a standard. And the only things that changed was the layer on top. For the browser, everything stayed the same, so no changes. But it became a binary protocol, and where everything was like text in HTTP1 with headers and everything. Now everything became a set of binary frames. So you literally take this request over response, you cut it, you chop it into uniform blocks, almost like shipping containers, and you just ship it back to request to the browser. So now you open a single connection, and you can take those little frames that you chopped a page into, and you just send them one by one. And a single frame could have data, like the text of HTML page. It could have headers, more data from different requests. So you don't open a new connection, you have a single connection, and all the different resources just kind of go through conveyor belt. You can also define priorities. So, and you do it by giving weights to certain resources. So for example, you can give to this resource, let's say this is a page and this is a font. And you say the page has priority 12 or weight 12, and the font has priority 4, because the page is more important. So the ratio is 3:1, but means for every 3 frames of a page, you'll send 1 frame of resource B. So hopefully the page loads faster. You can also define dependencies. That means load this first and then load that one. And you can have a graph, load this first, then this resource, and then give to this resource priority with a ratio 3:1. Cookies, right? I showed this GitHub request. We send a lot of stuff, and we have to send cookies with every request, right? Because you don't want to load images without cookies. So the GitHub request, for example, contains more than 2,000 characters, which is almost as long as half of original HTTP protocol spec. So now they do a compression, because you send the same headers, right? Like with text, you send the same kind of method, host, everything over and over. But now these are encoded with indices. And then when you send a new request, you don't send the same information, you just send the difference. So when you load the page, you send everything. When you load an image from that domain, you just say, oh, the path is different, everything else stays the same. So completely collapses. And so you have one headers frame, and the second header frame is pretty much nothing. And then, yeah, you do encoding of all the common things, which, by the way, when they first released this, had a huge security hole. Everyone could guess the headers just by looking at this. So they had to iterate quickly to fix it. HTTP2 is already supported pretty much everywhere, right? It's one big revolution in browsers that no one has heard of, and that's a good thing, right? That means they did a nice job maintaining the API and just substituting how they implemented it to make it faster and better. The traffic is growing. So this was summer of last year, but now it's definitely more than that. It's amazing how hard it is to actually find the accurate stats for this. You would think that all this, backbones, internet transmission companies, people like Cloudflare or Chrome would actually have these numbers like right away every day, like a stock market. No, just incredibly hard. But they do say that they collapsed the most important metric. That means how many requests do you have to make to a domain, right? Because that was killing, for each request going, creating a TLS connection, getting the data back. Now it's all going over the same channel multiplex. And so that is working. So that's great. The internet is fast. What's great for this crowd, if you're interested in HTTP and performance and HTTP2, both of these books are free to read online. Ilya Grigorik works for Google. Unbelievably good book. The little diagrams and pictures for HTTP2 come from his book, and now it's free to read online. A super huge resource for anyone interested in performance. And Daniel has his book online explaining HTTP2 in human words, and this is a person who wrote Curl, so he knows what he's talking about. By the way, did you know that he tried to get an American visa to come here for a presentation? I couldn't. Right? Yes. So that's interesting. Okay. If you want to see HTTP2, how it looks like on frames, you can open Chrome internals and Chrome //net-internals, and you will see how it looks. There is a new feature. Everything else that I showed before was just internal implementation of existing HTTP2 protocol, right? So the browser didn't have to do anything differently. The server didn't have to do almost anything differently. But there is one new feature that was added for performance, and that's called server push. And the main idea is that, let's say a client is loading this page. So it says, hey, get me index.html. The server sends index.html. The browser renders it and finds, oh, I see photo. It's an image. Let me ask for this photo. And the browser sends a photo. And so there is a huge time gap between when the browser receives the HTML page and when it asks for a photo. But that's not important. The important thing is when you got the page, before you showed the photo, there was a significant lag, right? That's what the user sees, like, oh, empty page. And then, oh, there was an image. I don't see anything. Oh, now I see it. So huge performance issue. So server push is this. I'm asking you for index.html. You give me index.html, but then you also know other resources that the user will ask immediately. So you push an image preemptively. So the browser gets the index.html, looks at that, asks for photo JPEG. Oh, I already have it. Great. So you have no delay. You only have this latency. Great for the user experience, right? So the things you should push is your styles, maybe some JavaScript. Not a lot, but a little bit. Okay? Because it used to be that people would inline like critical CSS, critical JavaScript. So you send it with a page. Now you don't have to do that. Except, it's easy to implement as well. Except it doesn't really work very well. So I tried it, right? I was doing my push and shove. I'm just trying to see. So this is push for like 300-400 milliseconds for images. And this was normal HTTP. And it says 20, 30 milliseconds. So what the hell? Why is it so slow? Well, turns out the server push doesn't really know what you already have. So it will preemptively always push new stuff. So if you're pushing images but are already cached by your browser, it's actually slower because you're pushing this binary thing multiplex with a page, so you're slowing everyone down. So people wrote a bunch of blog posts, and everyone was trying to come up with the best name, right? Like being pushy, right? It's just, I mean, I appreciate pun as much as anyone else, but still, like, you know, it was a push too far. So there is a new proposal, and it's called Cache Digest. When you're asking for a page, you also give a digest of all the resources you already have cached. Like, give me index.html. I already have app CSS and a hash, so you can push new version. And I have app.js. And so the server says, oh, I'm just giving you a page because I see that you already have other resources. I'm not going to push for that. And so the advice is like, don't do that yet. Let the browser do normal caching. That's probably more performant than trying to do what you're trying to do. So HTTP 2 is changing really the best performance practices. You know, there were best performance practices before, right? Like reduce DNS lookups. Don't try to fetch 200 resources from 200 domains. But the really like important ones were really concatenate all resources, like minimize the number of round trips. And now it changed, right? So now it's like, don't do that. Multiplexing will take care of it. But my only advice is for you is freaking do less work, load less stuff, right? I don't need all your images at once. Okay, here's my pet peeve. Here's what really grinds my gears. Who cares about custom fonts? Oh, oh, damn it! I have to. Ooh, the crowd goes wild and the speakers, you know, lynched. No, really, come on, right? The number of times I see, especially like a flash of font, and when the custom font comes in, and amount of articles I see about performance, how to load different types of fonts for every browser. And it's like, just give me standard font and let me read your stuff. But anyway, so do less work. That's my only advice. So to summarize, HTTP 2, that is out today, but you're using right now to like look and read online, has only 4 main features. It does multiplexing. It doesn't open new connection. It has a single connection shared. It compresses everything, especially the headers and all the binary things. Makes it easier and more performant. You can define which resources should be loaded first. That should lead to the first, you know, paint faster. And there is resource push. Don't use it. Every thing that I just said had a security hole, so they had to quickly come around with workarounds to solve it. But now, while we're doing that, there is actually even more advanced stuff that came out. So HTTP 2, despite everything, has a huge problem. So imagine you have a stream, a single stream, and you multiplex all these frames from different resources. Now, if you lose one of the packets, right, what happens? Well, TCP says, no, 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 no. I'll deliver everything in the order I promised. So all of you, wait. Let me resend that particular frame. That means you're slowing down everyone. So if you have no packet loss, HTTP 2 is faster. When you start losing frames, everything else is blocked. So all of a sudden, HTTP 2 looks horrible. All right? So HTTP 2 has to use a secure layer, TLS, and then it uses TCP. That's what guarantees all the packets will be delivered in the same order as you sent. Good. So now there is a new protocol called QUIC that uses the other protocol, the stepchild of protocols called UDP. UDP doesn't guarantee delivery. Now you ask yourself, well, why can't someone write a protocol that's just like TCP but doesn't guarantee it? Okay, there are only TCP and UDP, because if you want to write a third protocol, you have to convince everyone, and I mean hardware, software, OSs, everyone, all the people who really hate each other, to add this third protocol on your behalf. So the only game in town, if you don't like TCP, is UDP. So Quick implement uses UDP. It's like speedy, so binary, but over unreliable data frames. And it works great. And I have a timeline, but the only important thing is that we are 2018. HTTP2 became standard 3 years. The work on Quick started 5 years ago. So it's close to actually being finished and becoming a protocol. It's been battle tested. And if you use Chrome properties, you're using Quick right now. And you just don't know about it. Because to the browser, it's the same thing. It's just under the hood, uses different things. You can go to Chrome flags, enable Quick, and see what's going on. And if you show protocol column in your network, you will see the Quick protocol today. Secure as needed. WebRTC, when you look at slides, go through this column, press down. It's actually a funny column. I have Silicon Valley references, but I'm going to skip it. But I have to say. So I'm just going to close with a couple of conclusions. So HTTP was created to solve a real-world problem. Every version of HTTP was trying to solve a problem discovered in the real world. And that problem, oh, we need performance, oh, we need security, oh, we need method, was not discovered until more people start using it in different scenarios. So HTTP 0.9 was just loading static documents. 1 was in response to the growing popularity for the web. AJAX, because we didn't want to reload the page to fetch a little bit of data. WebSockets needed for real-time communication. Service Worker, we needed good caching and scriptable caching. HTTP2 was just trying to solve the performance in a real-world scenario. Quick is alternative solution to performance problem in response to the shortcomings of HTTP2. So I guarantee that tomorrow will be a new version of HTTP or Quick, and it will try to solve problems that we discovered using HTTP2 and Quick today. And the only things that stay constant, but don't have this iteration, are failed products. Does anyone have a Zune version 2.2? Anyone? Exactly. It's not your parents' HTTP. And thank you so much. The slides are all online. And if you have any questions, I'll be outside. Thank you.